Welcome back. So in this video we are going to cover question number 2. And it says that find magnitude and direction of the instantaneous velocity at t equals 0, t equals 1 second, and t equals 2 seconds. So in comparison to number 1, number 2 is asking for the instantaneous velocity, okay? So as you can see from the question itself, it's asking for what is the velocity what is the velocity of the particle when the time is 1 second. It's not asking from 1 to 2 like how we have it in question number 1. Okay, so keep that in mind. Okay, so let's why don't we begin? So I just want to rewrite this equation again, and the way that I like to write it would be not, vector RT. I like to write it as x of t, the function of x in terms of t is 4 centimeters plus 5 centimeters per square, t square, and then I don't think I have enough space, so why don't I move it here? And it's going to be 5 centimeter per second t, and then okay. So now we have it. And now it's asking for the instantaneous velocity, right? So and it's asking for that. Why don't we do this? So now we have to find the instantaneous velocity. First, we have to get this equation into, the equation of velocity. So how do we do that? We take its derivatives, okay? So let's write it out here. Vt equals, so 4 centimeters is just going to be 0 plus, and then 2.5 centimeters is just the coefficient. We bring the 2 out front times 2.5, that will give us 5ti, right? And now here we're just going to be left with 5 centimeter j. Okay, I should put the centimeter here. So in another word, the derivative of the position equation will give us the velocity equation. Okay, so yeah, forgot. Centimeter j hat. Okay, now we have it here. Okay, so I just want to do a very quick recall here. That the instantaneous velocity, or in v instead, not Instagram, because we don't care about Instagram. We care about physics here. Physics is cooler. Yep. The limit as t approaches 0 give us the change of t, and then thus the derivative of the position x over the derivative of time. Okay, this is just a quick recall. This is basically the same thing as what we derived from here. Okay, so now we have the equation. Okay, I'll keep it. Okay, so now we can just plug in when t equals 0. Pick a brighter color. When t equals 0, v of t is going to be 0I plus 5 centimeter j. Thus, this is going to give us just 5 centimeter j hat in the y direction. And when t equals 1 second, we're just doing it, we're just using these times here now. Okay, so v1 equals 5 centimeter 5 centimeters plus 5 centimeter j, right? Okay, so when t equals 2 second, vt, that's going to be 10 centimeters I plus 5 centimeter j. So let's also, okay, for magnitude, I'm going to use a different color, maybe the pink color for magnitude, or the instantaneous speed, okay, of the particle. Alright, so how do we find magnitude? Well, let's do, maybe we have to do another recall, right? To find the magnitude, it will be zv for vx squared plus vy squared, okay? Okay, so let's find the magnitude for when t equals 0. T equals 0, we have v equals the square root of, well, in the x direction, the velocity vector is actually just 0 hat, so it's just going to be 0 plus 5 squared, yes, so the magnitude is going to be, well, 5, it's just going to be 5 centimeters squared, okay? And also here, when t equals 1, we do the magnitude, it's going to be 5 squared plus 5 squared, going to be square root of 50, and when we take that from our calculator, because I do want to get a decimal point, unless I can, you know, I could get a, what is it? I could do this just for fun if I wanted to do it. It's this, but if you want to find the exact answer, or, well, this is the exact answer, but if I want to find it in decimal form, then it will just be 7 point, I believe it was 0.7 centimeters squared. Okay. Now we're going to do when t equals 2, right? So when t equals 2, it's going to be square root of 10 squared plus 5 squared, and then now we have 100 plus 25, it's going to be 125, and what happens when we take the square root of that? Okay, well, we have another way, it'll be 5 there, right? So just be 5 to the 5, and what exactly in decimal point is that? It's actually 11.18 centimeter. Okay. Alright, so there we have it. Yes, we have it now. But we also want to find, so we have the magnitude for each time, right? Maybe I'll circle it. I can circle it. So this is the magnitude when t equals 0, and this is the magnitude when t equals what? 1. And this is the magnitude when t equals 2. Now we want to find the direction. So recall how to find the direction. Direction. I'm gonna roll my tongue while saying direction, but it's not working. Alright, so how do we find the direction? We know that we can use